Hello, my name is Jake Merrick, and today I will be the teacher. And today, we'll be talking about probability. Unfortunately, my Mac computer is having some issues, so I'm unable to be recording the video through the Mac. So that is why I'm recording on my phone. Hopefully, you'll be able to still see the screen clearly and be able to follow me without having any issues or confusion. So probability, what is it? Probability, in the most simplest way possible I can kind of put it, is the chance or likelihood that some event will occur. Why is probability important? Probability is important because as humans, as just people in general, most of us strive to come to understanding of something or concept. Probability is a way that allows you to understand a problem more simply. In other words, probability in a sense allows you to develop a better understanding of an issue or problem that you are attempting to solve. Because in general, most humans are curious. We seek answers. It's just kind of who we are as people. So probability is a way that you can kind of develop a better understanding of an issue that you're trying to solve. So some simple terms that I think are important to understanding probability. As it says here, probability is a mathematical tool used to study randomness. Obviously, there are different types of probability problems. You got the coin problems, card problems, but what we'll be looking at today is some kind of basic one, just to kind of get you solely into understanding the issue. So when in statistics, we generally want to study a population. As in any kind of statistical problem, you want as many controlled variables as possible. For example, when you are conducting an experiment in statistics, you want to kind of first you want to get a population. That population can be a collection of people, things, objects, really anything. It just kind of has to be a population of some number of things. And when you're studying a population, you want to select a sample. So a sample is basically a portion or a subset of a larger population. And the reason for a sample is you want to kind of gain information about the population in some way. So, for example, as it says right here, if you wish to compute the overall grade point average at your school, it would make sense to select a sample of students who attend the school, right? Because let's say you want to compute the overall grade point average at your school. You're not going to get a sample of grade point averages of other students at another school. It's this specific population that you're trying to get a sample from. And so that's why you just kind of got to be very specific. So when you collect your data and you get the grade point averages from each student at your school, you want to find kind of the average of them. So that kind of brings us to a statistic. So what is a statistic? A statistic is a number that represents a property of the sample. For example, here's another example we can look at. If we consider one math class to be a sample of the population of all math classes, then the average number of points earned by students in that one math class at the end of the term is an example of a statistic. So a statistic is basically an estimate of a population parameter. Now, what is a parameter? A parameter is a number that is a property of the population. So in other words, since all math classes are in a sense part of the population, then the average number of points earned by the student over all math classes is an example of a parameter. I know that's probably sounds a little bit confusing, but basically a parameter is a number that is a property of the population. So basically what we learned from those examples is that when you're conducting a statistical experiment or study, you want to control as many variables as possible. You don't want a biased sample, a biased population. You want everything as accurate and you could say organic as possible. You don't want to alter really anything because you want the most accurate. Because at the end of the day, you want the most accurate results. So we can maybe go to a kind of more simple example. So let's say, so we're kind of looking at a probability example with beads. Beads you can make bracelets with. So there are 6 beads in a bag. 3 are red, 2 are yellow, and 1 is blue. So what is the probability of picking a yellow? So obviously this is pretty simple. There's 6 beads total. 2 are yellow, 1 is blue, 3 are red. Those add up. 3 red, 2 yellow, 1 blue add up to 6 total beads, right? But we want to know the probability of yellow. So there's 2 yellows out of 6 beads. And so how do you find the probability of yellow beads in the 6 beads in the bag? Well, if you go back to here, what is probability? It's the number of ways of achieving success, which is, in this case, 2, because there are 2 yellow beads, and those are 2 ways to, if you find a yellow one, then in a sense you're kind of achieving success. So 2 would be up here, and then the total number of possible outcomes. Well, if there's 6 beads, and each time you take out a bead, there's going to be 6 chances because there's 6 beads. In other words, there's not going to be 8 chances, because if you were to take 8 beads out of the bag, you would be replicating one of the beads that you were taking out. So it would be 2 over 6, which gets reduced down to 1/3. And that's basic probability. Another example. Oops. Apologize for that. Another example we can look at is another similar kind of question. So there's a bag full of colored balls, red, blue, green, and orange. Balls are picked out and replaced. John did this 1,000 times and obtained the following results. So right here are the results. So the first question asks, what is the probability of picking a green ball? So how many green balls are there? 450, right? And how many total times did John pull out a ball? 1,000. So we go back up here. So what was the number of ways of achieving success? Well, in order to achieve a success in this case, you kind of got to take action. And John took action by pulling out the balls. Actually, I'm sorry. The number of ways of achieving success is what he was trying to find. And the question asked, what is the probability of picking a green ball? So because he picked green 450 times, 450 balls, that would be on top. That would be the numerator. And so then the total number of possible outcomes, which obviously is 1,000 because he did that 1,000 times, would go on the denominator. So simply you would do 450 divided by 1,000, and you get 0.45, or in other words, let's say 45%. So 45% of the time, John would pick a green ball out of the bag. So let's just say if there are 100 balls in the bag, how many of them are likely to be green? So as it says above, there are 450 green balls, right? And then John reached in the bag and pulled out a ball 1,000 times. So as we learned in the previous question, about 45% of the time John's picking out a green ball. But out of 100 balls, 45 are going to be green. How do we know that? Because you would sense. So basically, this question is asking if there are 100 balls in the bag instead of 1,000. So in this case, there's 1,000, and he chose green 450 times. So it'd be 450 divided by 1,000, which is 0.445. But if you reduce 1,000 down to 100 balls, you would get 45. And how do you do that? Well, you would take 45 divided by 100, because this 1,000 changed to 100 balls, from the bag. So you would simply get 45 out of 100, which within itself is 45. These are kind of simple probability problems you see. Obviously, there are more complex ones, but I simply just wanted to familiarize you all with the basics of probability. I hope this helps, and so thanks. Enjoy the rest of your day.